Duberstein. I am a multimedia producer. I'm the lead for heliophysics at NASA's Goddard Space Flight Center up in Greenbelt. And so what that means, simply put, is I make movies about the sun. And so a lot of what we do is designed entirely for the web. And you'll notice this shameless plug above me here. We have an excellent social media team. I used to lead that before I took over heliophysics for a time. And I have to admit, it kind of shaped the way that I thought about video. And the work we do, we're part newsroom, and we're part graphic design, and we're a whole bunch of different interesting things. But what really works on the internet is video. You've probably noticed that your friends aren't sending you cat essays, they're sending you cat videos. So with this kind of thing in mind, we're not adding cats to our NASA stories, but rather we're looking toward something that's less narrative driven and more purely visual. Something that just brings you in through the eyes and encourages you to ask questions. And that's been a lot of fun to work on that kind of material. Both my co-producer, Scott Wiesinger, and I have MFA backgrounds, and we're always very excited to come and bring an art perspective to the science data. So let's go ahead and we'll watch an example of that now. So what we have here isn't your traditional science video. We don't have a narrative explaining what you're seeing. We don't know the full science story, and that's kind of the point. We're trying to give you something a little intriguing that makes you want to do just one more click to maybe read that article or Google something about what you saw here, to have a kind of interactive internal conversation, with us and with the people, the viewers, in getting to know a little bit more about something that's very familiar to all of us, which is the sun. And we've all seen it before, but probably not like this. And so with this piece, there's a lot of really slow pans. It was kind of designed to be a tour of something unfamiliar. We're exploring some kind of strange landscape. And I worked in Photoshop to get really deep inky blues, so it was something similar to what you'd get if you were doodling with a ballpoint pen. Really hard outlines around the reds and yellows, something like a comic book. I'm coming from a fine arts background. I really like the idea of, even though it's all digital, having the sense of touch to it. And it played really well online. People liked it a lot, even though it's kind of stealth science when you think about it. But before you get to making anything like that, there's a whole other process, and we're going to talk a little bit about that today. So solar footage itself is beautiful. It's breathtaking. You might think you'd look at it and not need a whole lot else to do. But that's actually not true. There's a whole lot of material to work with here. I mean, the sun itself is a bunch of contrasts, and not just in the literal sense. Yes, there are strong highlights and deep darks, but you have this sphere that doesn't really move very much within itself, but then within itself, within the circle, there's actually a lot of motion. My video is playing rather slowly, but believe me, there's a lot of motion on a good day. So what does it take to even just get imagery like this? Well, I work with a team. We have our engineers, we have our heliophysics. I have a visualizer, Tom Bridgman, who helps us with our data, my co-producer, Scott. There's a lot of people behind bringing this to the public. It isn't something that's simply a camera rolling. There's a whole process behind it. Now, people often ask us, is there a place I can go see this live? I'd love to see the sun streaming. Well, so would I. Getting 1 minute of this footage, we estimate it's about 10 hours of work, and that's among multiple people. It's pretty mind-blowing that we're getting it at all, but it is unfortunately, not fast and not real time. So how are we getting it? How does this work? It comes from the Solar Dynamics Observatory. It's an adorable little spacecraft right here. It looks at the sun. It is pretty cute for a spacecraft, isn't it? It looks at the sun, and it takes in some light. The light becomes data. All those zeros and ones bounce down to White Sands, New Mexico, and then they're going to go off to Stanford a little bit here. There they go. And then they're at the servers in Stanford, and then our visualizer can access them from there. So SDO will make an image of the sun once every 12 seconds. So that's another reason we're not real time. I guess you could sit there, right at the servers and download another image once every 12 seconds, but that's not really a very satisfying video to watch. So what we do is a process that I guess is easiest to think about in an analogy to old school film photography. So you let in the light and an image is created, but it takes a little while, separate process, to actually develop that image. So how that's similar to us is that the data comes down, and then our visualizers are our dark room. They take the data and they code it into being an image. And for any programmers out there, it's Fortran, if you think that's funny. So it's an old school coding language to bring us the state-of-the-art view of the sun. And the analogy to photography only holds up so far, in that everything we're used to seeing is visible light. There's only a certain spectrum of light that our eyes here on Earth can really deal with, that we're able to perceive. So the images in our photos are visual light. The images in SDO are not visible light. They're extreme ultraviolet. Our eyes can't see this. And the spacecraft takes it in 7 different wavelengths. We talk about the wavelengths by their measurement in angstroms. So the really pretty gold right there, that's the 171. The orange is the 304. And they're color-coded. And people will ask me, is the sun really green, or is there a part that's really yellow? Why are there all these colors? Well, they're false color like a map. They help us to be able to differentiate between the different wavelengths and to talk about them. So because all of this starts as frames, your creative decisions have to start very early. When you know you want to be making a video of something that happened on the sun, you need to know the start and end date of it. You need to know what cadence you want it at. Certain events look better at certain rates. You need to know what wavelength got it best. Not all wavelengths are equal. Some are better for flares, some are better for prominence eruptions, like what you just saw there. Some just show the pretty loops better. And also, it's just really important to be able to be patient, to realize that the visualizers are dealing with the pipeline with however the spacecraft is functioning that day. So when you get it from them, it doesn't look like this yet. This is something that comes later. So I'll show you what it looks like when we get it. I put in my request, my visualizer is all right, I'll have it for you in a little bit. This is what it looks like when we get it. It's a dramatization. My co-producer does all his own stunts, but they're very big. It's a 4K image, and so when you open it up on your laptop, I think I know what it's like to hear a MacBook cry. It's very hard on it, and so we request these by the thousands. There are thousands and thousands of frames when we do this, because remember, best we can do, just 1 frame every 12 seconds. So these are enormous, enormous files. And we take all of these files and we turn them into footage. And actually, you probably don't have your own visualizer at home, but you can make similar movies. There's a program called JHelioViewer. If you go to jhelioviewer.org, there's a version of it. Why am I not showing up here? I can see it. Here we go. All right, so JHelioViewer will allow you to do something similar. You can request time spans and wavelengths and download your own frames. And also the SDO website will let you do something too. Get your own package of frames. But there is a difference in quality. So we have an advantage having our wonderful visualizer Tom being able to work for us, because you can really see the difference between coming from code and coming from JHelioViewer. It's just thank you for the lights, the quality in the loops, what really makes the footage, I think, so much fun, all that detail. The benefit of having those large files kind of gets compromised a little bit in the other options. So you take all your frames and you turn them into footage, and what you're given is a full disk of the sun. It's this 4K full circle. You have to make all their different editorial choices from there. And you could, if you like this the way it is, you could very well be done, but we have a hard time leaving anything well enough alone. This is just a static shot. There is so much more emotional potential to draw people in and really highlight certain areas. And over time, we've actually developed different techniques to really bring out a little more emotional punch to the images. So you notice the one on the top, and SDO has existed for only 3 years, so we've been refining this over time. The one on the bottom is more close to the color I would get from our visualizer if I asked for a 304 image. And then the one on the top here is what happens after we do our own color correction. Both of them have camera moves on them, both of them have been cropped, and there's been other kinds of adjustments to them. But over time, we've really kind of refined it to give it a little more of an impact. And every now and then, you get a frame that has something kind of wrong with it. This happens. Sometime the spacecraft might have an issue. There might be something with the data pipeline. The moon might get in the way, which is actually what happened here. I actually think this is great. It adds a level of reflexivity to it. It reminds us of our tools. It reminds us of our quest to better understand our sun and our solar system. And it also reminds us that we have so much further to go. And I don't think that's a bad thing to think about, because it reminds you that what comes next will be even better. It will be amazing. And that'll be great for both science and art. Thank you.